Okay, let's take a look at some of the code here. So let's check the working directory to make sure that I'm in the right directory where my downloaded file and downloaded and unzipped file is. I renamed it this, you don't have to rename it, but you do need to use something like read table instead of read.csv, read.table, and then specify that the separator is this. And just to show you what I mean, here is the file, and you can see the first column is age, the next column is job, and so on. But separators are not commas. Separators are not commas anywhere. This is not a comma separated file. Whereas, for example, this one I converted to comma separated, but you don't have to do that actually. But this is comma separated. So that's when you would use read.csv if you know that it is comma separated. But in our case, it's actually not comma separated. We have this one. So you can use this. You can use read.table, the name of the file, the separator, which is this, you have to put it in these quotes, and this file has a header, means has column names, so you need to say header equals true, so you have to specify that it has a header. So if you run this and then make sure that it's converted to a data frame, so if we check str, which we just learned, df, it already is a data frame, but I like to just be careful, and I'm just going to repeat it. So I'm going to make sure that it's data frame, put it in df in the as data frame function. So now it's a data frame, and then I can do str. Oops, what did I do? Sorry, that was not right. That's an example of, you can't just select part of a line. You either have to select the whole line or just none of the line. Just put the insertion bar there and run it. Okay, there. Now it ran. And now I could do str and it's still going to be a data frame. Let's do that just because we've only recently learned about str. So let's try that. So here you can see that it's a data frame. It tells you how many observations, how many rows there are, how many variables there are, and then it lists the variables. Starts with age, it says it's an integer, and it's got these kinds of values. It says job is a factor, and we've learned about factors. It has 12 levels, and here are some of the levels. Marital status is also a factor, like divorced, married. Education is a factor. Now you can tell this function not to, there's another argument that you can set that so that it won't turn these things automatically into factors. But for now I'm going to leave it as let it do it. Default is a factor, balance is an integer, and so on. Okay, this is bank data. Okay, now after we've run this command, we've sort of redundantly made sure that it's a data frame, we can check the names of the variables with this command. So let's try that. So age, job, marital, education, and so on, housing, loan, and all of this data, all of these variable names. Okay, now, let's try this one. So this is an alternative to doing the view, capital VIEW, which we could also do, but let's try this. This is print data.frame. Let's see what that does. So that, it's not so pretty actually. It prints it out. You can see age, job, marital, education, default balance, but then runs out of space and it goes to the next line, which is kind of messy. We could also do view df, and that makes it a little, that makes it, whoops, that makes it, let's run that. That's here. Now we see it in this kind of like a spreadsheet, but I'll close that. Now if you want to clear all of this, I think we've mentioned it before, but I'll press Control L and that will clear the screen there, like that. Okay, now let's go to this one, which we spoke about. And so, okay, so we've seen this before. We've just finished talking about what this does in a different context. It wasn't this data frame, it was our own data frame that we made up with just two variables, but it's the same idea. So here we're saying this is a vector. In fact, maybe we ought to do that line first. Let's do head because I don't want to look at every value. df $sign age. Okay, and let's just run that. So you can see that it's a vector, and some of the values, so 30, 33, and so on. Those are the first few values. Now, some of them are less than 30. In fact, all of these are less than 30, but not necessarily all of the data frame, the age variables are less than 30. So this, anyway, is going to produce, for each row, it's either true or it's false, that age is less than 30. So for each row, we're going to get a true or false, but since this is checking for every row, we're going to get a big long vector of true and false, what we call a Boolean vector. And I'm just going to look at the head, which is not going to give us enough to see any trues, is it? But anyway, I'll just run it. So they're all false, but if I made this, what, less than 34, or let's say 36, if I ran that, and some of them will be true. So this one is less than 36, this is not, and this is. So most of them are true in that case. Okay, but the idea is that it's going to produce a Boolean vector. Okay, now let's take a look at this statement. Okay, so now in here, what I have is, so this is a vector, and some of these are going to be true, and sometimes this statement is going to be true, and sometimes it's going to be false. And whenever it's true, now notice there's a comma here, because this is a data frame. But in this case, this is a data frame. And so what I'm extracting is, sometimes this is true, and sometimes it's false. So when it's true, this is, one more thing. Here's the comma. So what's here refers to the rows, and what's here refers to the columns. So again, sometimes this is true and sometimes it's false. So when it's true, I'm going to select that row. And when it's false, I'm not going to select that row. So what does that mean? I'm only going to select the rows where age is less than 30. So what I'm going to do is this syntax will extract all the rows that are less than 30 and leave out the rest of them. Okay? So let's try it. Okay, so it's much too long, but I might try it with head. Let's see what head does. Let's try that. Okay, so here's row 14. Here's row 19. So these are the rows where age is less than 30, and you can see age is less than 30, age is less than 30, age is less than 30. So apparently in rows 1 through 13, age was not less than 30, and we saw that like at the beginning. Most of the all of the ages that we saw were greater than 30, and actually that's true all the way up to row 14. So row 14 is the first row where the age is less than 30, and then there are a bunch of rows where age is greater than not less than 30, and then row 19, again it's less than 30, it's 25, and row 25 again. So the point here is that this will extract from this data frame only the rows that satisfy this condition, that is where this condition is true. And this condition says that age is less than 20. So it's only going to subtract the rows where age is less than 30. And this is very typical R code or R syntax. Okay? So that's what we're doing here. We're extracting only the rows. So I didn't have this head here before. So we're extracting only the rows where age is less than 30. Okay, now this is the same kind of thing. So what is this doing? Again, there's a comma here, just like there was a comma here. So that means whatever we're doing, we're talking about the rows, because this is in the row position. So what are we doing in this one? We're only extracting the row, we're extracting only those rows where this condition is true. So before it was where this condition was true, and this condition means where age is less than 30. Now it's where education is, this is the equals to sign, is equal to tertiary. So then we'll get a different set of rows. In fact, let's put a head around that and see which rows we get for that, which few of the rows that we get that satisfy that. Now we already saw that for this one, the first 13 rows didn't satisfy it. Now let's see about this one. So here, the third row satisfies tertiary. Education is tertiary. The fourth row also, education is tertiary. But the fifth row apparently isn't, but the sixth row is, and so on. So in this way we can extract rows based on these different conditions, like this one, or this one. Now remember, these, in the language of logic, these are statements. Statements are something that are true or false, but not both. So for each row, it's either true or it's false that age is less than 30. And for each row, it's either true or false that education is equal to tertiary. So these are logical statements. Okay, so we were then talking about making compound logical statements. And we can do that in this context as well. So what's the compound logical statement that we're going to make? We're going to take this one, and we have another one here. We're going to take this one, and we're going to put them together with an AND connector, or an AND operator, or the conjunction, as we called it, here. So we have, here again is the comma, so we're talking about the rows, we're making specifications on the rows, and we're making a compound specification or a compound statement. So this is, give me the rows where age is less than 30. This is not or, this is and. So where age is less than 30 and education is tertiary. So what? We're only going to get rows that satisfy both of these conditions. Which ones are going to satisfy both? And then later we want to examine the logic behind this and statement. So it's already clear, it's not like we really have to examine it, but we're going to do it formally. But it's already clear that the only time that we're going to get a row is one that satisfies this and this. So if it just satisfies this, no. If it just satisfies this, no. It has to satisfy both of them, which is very clear, but we're just going to sort of restate that formally. But anyway, before we do it, let's see what happens. But let's put this in a heads statement as well. And run it. Okay, so which are the rows that satisfy it? So not until row 25 do we get one where age is less than 30 and education is tertiary. And the next one is row 40, where age is less than 30, and education is tertiary. And you can see how this works. So this is really a compound statement here. And we just want to examine that in general or formally as logic, but it's not like we need to. It's very clear. Okay, now we could use or also, but we're not doing that yet, but we will. So let's stop this video and go back to the PowerPoint. Now there are some other ways that you can do this. There's a subset function, and you can use that, and maybe we'll talk about how to do that, but you can look it up and see how to use it. It will give us basically the same thing. Here in the subset function, forget about this n row, we don't need that. That's not part of what we're doing. But subset function, you specify the data frame there, and then you put in the condition there, next. That's how the subset function works, but it'll give you the same result. And then there's a much more impressive way to do it, kind of newer way, and that's using another library, but we won't cover that library much in this course because we're trying to get through some other things. We can't cover everything, but you can certainly look it up. It's called the dplyr library. But anyway, let's go back to the PowerPoint now and examine the formal structure of the logic here.